Good morning, dear students, and welcome to Vista's World Learning, an online educational platform. My name is Denzil, your science tutor for class 11. So let's get started with today's session. Today's session is a session 3 of the chapter measurement, and we will be discussing accuracy and precision. So what exactly does it mean the given object or given measurement is accurate and precise enough? So let's have a look at the definition of what is accuracy and precision. Accuracy is how close, is to measure as to how close the measured value is to the true value of the given quantity. So let me put this in a perspective that you understand. True value being the actual value of a given object. Let's say the length of the given object is about 10.54 centimeter. Now when you make a measurement, there you are limited by how much you can make the measurement to. This limitation will come under precision, but what we are looking at is an accuracy. So when you're making a measurement, you get 10.5 the first time when you make measurement. Remember, the actual measurement is the true value is 10.54. The first time when you make a measurement, you get the value 10.5. The second time when you make the same measurement, you get 10.2. Third time when you make the measurement, you get 10.1. Among these three measurements, which one is closest to the true value? That's right, 10.5. This is to show that the first measurement is very accurate compared to the other successive measurements. So this is where accuracy comes into the picture as to how close the given measurement is to the true value. On the other hand, precision is a measure as to the resolution or the limit of a quantity that has been measured. Limit meaning when you take a scale, the limit that you can make the measurement is only up to a millimeter, which is 0.1 centimeter. Now, if I want to measure more precisely as to 0.01 centimeter, you cannot just use a regular ruler. You have to use the other devices such as an instrument called Vernier Caliper. So limitations of a given instrument. Okay, so limitation of a given instrument tells you how precise the given instrument is. So again, one more example. The reason again here in this background picture, I have the board where you throw an arrow. Even the initial picture before this is a picture of this marksman, okay, who's drawn the bow and shot the arrow. This is to show you even in case of shooting an arrow, it needs certain precision and an accuracy. Precision depends upon the instrument which the marksman is using. Accuracy is to show how well the person is close, how well he shoots to that true value, which means the bullseye. So how consistently he shoots again is what is called a precision. So let us look into few more examples, but before that, a few examples of this, of accuracy and precision. Here's a ball. Now, when this ball is let go, what will happen? The ball will fall to the ground like that. Now, in order to determine this velocity of the ball, then you need two parameters, one which is the length, the other which is the time. Because velocity can be calculated V equals to distance by time. Now, in this particular case, when you have to determine the velocity, you use a ruler. Okay, you use a ruler in order to determine the length at which, the distance at which the ball falls to the ground. Similarly, to identify the time, you use a clock. Now, there are certain limitations for this ruler when it comes to making a measurement. That is because the precision of this instrument is only, when I say precision, it means the resolution. So let me make note of that. I'll put that as resolution of this ruler is only up to 0.1 centimeter. On the other hand, if you're using a clock, then the resolution of this would be only about 1 second. Now you have better instruments that gives you a better resolution, such as a Vernier Caliper. Vernier Caliper gives you a resolution which is 0.01 centimeter. So since it has a better resolution, we expect that the accuracy to also be better. On the other hand, for a better resolution in case of determining a time, you can use a stopwatch which is actually installed in your electronic gadgets. Your electronic gadgets consist of a stopwatch. So if I'm not mistaken, stopwatch would have seconds, and then you will have milliseconds, and you have the other lower forms of seconds. But let me just say about milliseconds, which is 1/1000th of a second. So better resolution means a better way of determining the true value of the object. So better resolution implies better method of determining the true value of the object. Now that does not be the case at all for each and every attempt that you make for a measurement. It does not happen each and every time. At times what happens when you make a measurement is that you go away from the true value, even though when you're using a better instrument. Those are the errors which we'll be discussing in the next session. But first, a quick question. Out of these two instruments, the question reads, a pencil's true value is about 10.56, which is of the two instrument. Which of the two instrument has a better accuracy and precision? So you have instrument number 1 and an instrument number 2. The instrument number 1 has a resolution which is 0.1 centimeter and the measure is about 10.5 centimeter. On the other hand, instrument 2 has a resolution which is of 0.01 centimeter and a measure which is 10.46 centimeter. Among these two instruments, which one has a better accuracy and precision? So remember, here the true value of the length of the pencil is 10.56 centimeter. The actual value of the pencil, the measure of the pencil is 10.56 centimeter. Which of the two has a better accuracy and precision? Accuracy depends, precision, first let's discuss the precision and then we'll discuss the accuracy. For precision, you need better resolution. So in the first case, the resolution is only about 0.1 centimeter. And the second case, you have 0.01 centimeter. So among these two, which one has a better precision? Accuracy is far better in this case because you can make better measurement using this instrument too. Therefore, precision is better in case of instrument 2 compared to instrument 1. Now what about the accuracy? Among these two instruments, which one will have better accuracy? To find the better accuracy, we need to know if the measurement is close to the true value. The true value is about 10.56. Among these two, which one has a better measurement, which is close to the true value, is 10.5. 10.5 is closer towards the true value compared to 10.46. Therefore, accuracy is better in case of instrument 1. So here we have such a case where even with a better precision instrument, accuracy is not obtained. Why so? Why is there no better accuracy even though we are using a precision instrument? Now the reason may be listed down in what is called as an error. While making a measurement, we tend to make an error. So what are the different types of error that you make when it comes to measuring an instrument? The different types of error can be classified into two sorts, one called the systematic error and the other called the random error. So let's look under systematic errors. What are the different types of systematic errors? So in case of a systematic error, the error can be due to instrument. The instrument itself can be flawed. There might be some defects in the instrument. Therefore, you're not able to make a better measurement. Here's an example which I think you might recollect from your school days, because these scales, which are of broken sorts, have been used by many students even today. Broken scales, as you see, you cannot observe where the 0 and 1 is located. And even the other part of the scale is broken. It's very common for students to use this scale. Sometimes I've seen students using an ID card in order to draw lines. Kindly avoid doing that. A scale just costs only about 5 rupees. You can go ahead and purchase a brand new scale, but do not use a broken scale. So using a broken scale, a broken instrument, or flawed or defective instrument gives you an instrumental error. And when you have an instrumental error, your accuracy will also reduce. Now the second systematic error is the error in the technique or the procedure. When you have to conduct the measurement, there's a procedure in where you conduct this measurement. Here's one such example. Let's say an object which is placed, a pencil or a pen, okay, and you're trying to determine the length of the pencil or the pen. Now, how would you determine this length of pencil and a pen? Using a ruler. Now, you need to make sure that the two objects are parallel to each other. Now, if they're not parallel, if it is something like this, you see, you have this pen or a pencil which is placed horizontal, but this scale is slightly tilted. Now, if you're trying to make a measurement, you get a different value which is away from its true value. So this is error due to the technique or the procedure when it comes to measuring a given object. There's also a third type of error, the final type of error under systematic, which is a personal error. A personal error, particularly what is called as a parallax. So to help you understand this parallax, here's what happens. If an object which is placed, again a pencil or a pen, okay, and you're trying to measure the length of the pencil or the pen, but this time when you have to make a measurement, let's say you place the scale and you look sideways, you try to make the measurement sideways to the scale. When you try to determine sideways, what happens is you get an entirely different number. So which means you are not close to the true value of the measure of an actual pencil. So what would be the right method in order to determine the length of a given object using a ruler? One, first of all, conducting such measurement by when you're moving sideways is what is known as a parallax error. So when you move this side, you get a different number. When you look from the other side, you get a different number. So you get a parallax error. So how do you make an actual measurement? What is the right method is to place the scale which is close to the object. When you're making the measurement, always look up, look at the value which is straight towards the scale. So that will give you the true value of the given, a true measurement of a given object. So these are the various errors under systematic errors. Now let's look at errors under random errors. You have errors in random errors, you have errors that occur due to unpredictable fluctuation in experimental conditions, such as temperature, voltages, current. So these are the random errors that occur due to fluctuations. So examples are temperature. A sudden drop in temperature causes your measurement to change. Similarly, change in voltages. You might have observed even at home, the voltage is not constant, which is supposed to be at 220 volts. It is not constant for 220 volts. It keeps fluctuating in a range of 220 volts to 240 volts. Okay, so those of you who are still unaware of what is voltage, you can follow that in the next year's portion. Also, you have what is called as a voltage and a current. You'll be discussing some of the laws, Ohm's law, which you might have also learnt in 10th standard if I'm not mistaken. But nevertheless, temperature, voltage. Voltage is one such example where it fluctuates, and due to the fluctuation of voltage, your measurement can vary. And the next random error is the least count error. While calibrating a scale to determine what is the least count, first of all, is the lowest measurement, the smallest measurement you can make from a given instrument. Let's take your ruler, your scale. What is the smallest measurement that you can make on the scale? Go ahead, take your scale, have a look at the centimeter part and see what is the lowest or smallest measurement that you can make on the scale. The smallest measurement will be 0.1 centimeter. Now, if the calibration is wrong, when you have to make a least count error, instead of 0.1, you write 0.5. Then this leads to what is called as a least count error. Similarly, there's also another object which has a better precision than a scale, which is called Vernier Caliper. I'll erase that writings. This is what is called as a Vernier Caliper. Vernier Caliper is again an instrument that is used to measure the length of an object. Just like a scale which is used to measure the length of the object, Vernier Caliper is also used to measure the length of the object. So what is the difference between a scale and a Vernier Caliper? Scale has a lower resolution. Vernier Caliper has a better resolution. Therefore, it has more precision. More precision, more accuracy if you're conducting the experiment right without any errors. Now, if any such errors occur, how do we calculate them? So, what is a method of measuring an error? So, let's take an example here. Let's say you're making a measurement of a given object, a box. And you just need to find one dimension of that box, could be the length of that box. You're trying to determine what is the length of the box, so you make several measurements. Let's call this measurements as A1, A2, A3, A measurement by taking the difference between the Welcome back, dear students. Welcome back, dear students. So we were discussing about absolute error, the difference between the measurement that we make minus the true measurement of a given object. The difference is given by a Greek letter delta, and the difference between the two we write A1, delta A1. Similarly, we do delta A2, delta A3, and so on and so forth to delta AN. Now that we have plenty of difference between the measurements, which is the measurements that we make minus the true value, we need to find one absolute error. These are the individual absolute error for every measurement that we take, but we need one final absolute error. So how do we determine one final absolute error? Very simple, where delta A mean is equals to sum of all the individual absolute errors, delta A1 plus delta A2 plus so on and so forth to delta AN, whole divided by, you guessed it right, N. That will give you an absolute error. Now that we have identified the absolute error for a given measurement, next we can put this in a summation form where delta A mean is equals to sum of I is equals to 1 to N delta AI by N. So now that we have found what is an absolute mean, which is the individual delta A mean, we can also identify what the ratio of the error to its actual true value, which gives you a quantity called a relative error. So let's have a look at a relative error. A relative error is when you take the ratio of delta A, which is our absolute error, divided by the true value A mean. So let's put this as delta A mean divided by A mean. So this is what gives you a relative error. And why do we use a relative error? So that we find how much of percentage of error is in our measurement. So you can find the percentage of error in a given measurement by just taking the relative error and then multiplying it with 100. This will give you what is the percentage of error that is found in a given instrument. It could be a systematic error or it could be a random error, but it tells you overall how much of percentage of error exists in making a measurement. So keep these terms noted down. So we will use an example in order to find what will be the absolute, relative, as well as the percentage of error in a given instrument. So here we have a question that says, we measure the period of oscillation of a simple pendulum in a successive measurements. The reading turned out to be 2.63 seconds, 2.56 seconds, 2.42 seconds, 2.71 seconds, and 2.80 seconds. Calculate the absolute error, the relative error, and percentage error. Now, if you reflect back, I told you for several measurements that we take, in order to find the true value, what do? Sum of all these numbers divided by the total measurements that we make, the total number of measurements. And how many measurements are we making here? 1, 2, 3, 4, and 5. So now let us determine the true value of this given time. So true value, which is a mean, is equals to 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80 whole divided by 5. Since you're all in your PU as well as CBSE, you have the liberty to use a calculator, not your scientific calculator, but just a regular calculator, which has basic operations such as multiplication, addition, subtraction, and division. So go ahead, try to add them up and divide it by 5. By adding them up, if I'm not mistaken, you get a mean, which is nothing but, let me write it as capital T to show you it is the time taken, which is equals to 13.12 divided by 5. And 13.12 divided by 5 is about 2.624 seconds. Okay, 2.624 seconds. Now the measurement when you're making, if you look at how many decimal places that exist, it is only 2. But this result what you've obtained has 3 decimal places. So we need to put it to 2 decimal places by eliminating one of the decimal, which is 4, as 2.62 seconds. So how to eliminate when you have extra decimals, we will be discussing in the next session, which is about significant figures. Okay. So now that we have the time, which is t equals to 2.62, this would actually be the true value. Now that we have true value, we need to find what is the absolute error. And how would you find an absolute error? Measurement that you make minus the true value. So let's make a note of it here. Measurements that we make, the various measurements are 2.63, 2.56, 2.42, 2.71 and 2.80. To all of this, you subtract it by the true value, which is 2.62. 2.62, 2.62, 2.62, 2.62, and heck no. Okay, let's make note of that one more time. 2.63 minus 2.62, 2.56 minus 2.62, 2.42 minus 2.62, 2.71 minus 2.62, and 2.80 minus 2.62. Subtract, find the result for this difference between the two, which is 2.63 minus 2.62, which is about 0.01, and then 2.56 minus 2.62, minus 0.06. So similarly, go ahead with the remaining ones. So I'll quickly make note of those. 0.09 and 0.18. Now remember, what you have obtained here are the difference which is absolute error of a given measurement. These are absolute error. Now we need to find one final absolute error, one measurement which determines all the absolute errors, which means you take the mean of all this individual absolute errors. So delta T mean is equals to sum of those, which is 0.01 minus 0.06 minus 0.20 plus 0.09 plus 0.18, because I don't have enough space there, so I have written it down. Okay, add them, subtract them respectively, and you get 0.54 divided by 5, which is equals to 0.11 seconds. This is how you identify the absolute error of a given instrument. Now that we have determined the absolute error, we need to make a note of them. We need to make a note as to how to calculate the final time removing such errors. Now that we know so much is the error, we have to eliminate the error. How do we eliminate the error with our measurement? Let's say time true value is about 2.62. If I'm not mistaken, it should be 2.62. And now you're trying to eliminate the error. Now, if you want to eliminate the error, you should either add or subtract, but you're not sure if you have to add or subtract. So we write both, which is it could be an addition or it could be a subtraction of 0.11. So this is where eliminating an error involves an addition and subtraction, because we're not sure if we have to add or subtract in order to remove that error. It can only be confirmed by calibrating a given instrument if it can only be calibrated in order to remove that error. So now that we have this, which is 0.11, we can write time as either 2.62 plus 0.11, that gives you one value, and the other value is t equals to 2.62 minus 0.11. By adding and subtracting, you get two different values. One you get 2.73 and the other you get 2.51 seconds. All right, so you get two different values. Out of these two different values, which is 2.73 and 2.51, either one should be the right answer. Okay, so that is how you determine the actual true time and error. So which one is the 10th place? This one here is the 10th place. This one here is the 100th. So I believe that you have learned in the lower standards when it comes to naming the decimal places. The decimal places, you have the 10th place, 100th place, 1000th place with a TH at the end, right? So there's already an error in the 10th place. So what's the point of having the error in the 100th place? So we eliminate this. We don't want the error for the 100th place. So if you do not want the error for the 100th place, then the time should be reduced to 2.6 plus or minus 0.1 seconds. See what I've done here? I have eliminated the 100th place. Since I've eliminated the 100th place, I have 2.6 plus or minus 0.1. Okay, so kindly make note of that. Yes. Next, now that we have found the absolute error, next we have to find the relative error. And how do you find the relative error? Is to take the absolute error divided by its true value. Relative error are usually given by the symbol delta. This is a capital letter delta. Okay, so delta T, which is equals to 0.1, is the absolute error divided by 2.6. So 0.1 divided by 2.6, you get almost, not made note of that. So go ahead, try to calculate. Go ahead, try to calculate as to 0.1, 2.6 divided by 2.6. I'll do it as well. 0.1 divided by 2.6, which is about 0.0384. 0.0384. This is your relative error. Relative errors do not have units. Okay, so kindly don't make a note of units. It does not have units. Now this is the relative error. To find the percentage, what must you do is to multiply it with 100. So relative error, which is delta t, equals to 0.0384 multiplied with 100 to give you percentage of error into 100. So which would be 3.84%. This 3.84% can be approximated to 4%. This would be the percentage of error of a given instrument. So this is how you find step by step, where you first determine the absolute error and then you go about determining the relative error. And once you find what is the relative error, you multiply it with 100 to determine what would be the percentage of error. So that is all I have for today. Do visit us at www.we-learning.in to get more details about the classes. In the next session, I shall teach you what are significant figures and also how to combine errors. Different quantities having different errors, how to combine them together. We shall discuss them in the next class. Until then, everyone, take care and have a nice day. Bye-bye.